All right, so now we're going to turn to some examples of a function here. By the way, we want to take a look at the graph of this function. We certainly can. Let's just go ahead and do that. Y equals x to the third over 3 plus 1 divided by 4x. So we're looking at this curve here, particularly this side of the curve, has an asymptote, of course, at 0. So we're looking here at this side of the curve, right here, starting at x equals 1 and continuing over to x equals 5, which means I'm going to have to really kind of zoom in here to get my x equals 5 point in here. And so basically we're looking at between here and again, I'm going to have to zoom out some more. There. So we're looking at the point of intersection, the distance of this curve here between this point here at 1 and at x equals 5. That's what we're trying to find here, is the length of that curve. Okay, so we're going to start to work this out. It turns out we really need a lot of help in these problems. They need to be set up very nicely for us to be able to use the arc length formula right now. I mean, even a function as simple as y equals x right now, or y equals x squared, really just leaves us kind of lost. We'll later on be able to do it, but we need to develop techniques. So a lot of these, they have to be very crafted, and this is going to be one of them. And it's crafted, so it's going to be something we can do pretty easily for the most part. Well, pretty easily, I would say pretty easily. Not pretty easily, with some work, but it will work out. A lot of arc length formulas problems we're just going to have to use technology for. Okay, so arc length, first thing we need to do, the formula calls for the derivative, so we compute the derivative here. We multiply by 3, that would just give us an x squared. This would be 1/4 x to the minus 1. When you do that derivative, you'll get minus 1/4 x to the minus 2, which I'm going to go ahead and rewrite as 1/4x squared. And before I go putting this into my formula, I'm going to get a common denominator, which would be 4x squared. The first fraction, I'd have to multiply the top by 4x squared. That'll give me 4x to the 4th minus 1. Okay, so that's going to go into my distance formula here. The arc length will be the integral from 1 to 5 of the square root of 1 plus that stuff squared. 4x to the 4th minus 1 over 4x squared quantity squared. Okay, so we just need to start simplifying. So I'm going to do a little simplifying and come back to this square root stuff later. So first of all, I have this stuff squared. Oh, that's not x to, yeah, it is x to the 4th, yeah. Sorry. So squaring would mean on the top, we're multiplying by itself. So 4x to the 4th minus 1 times 4x to the 4th minus 1. And the bottom is just going to be simply 16x to the 4th. And so we go ahead and we multiply out. I'm going to go ahead and include the 1 now. So when we multiply out, that's going to be 16x to the 8th. All right, and then in the middle, you're going to have a 4x to the 4th and another one. They're both multiplied by minus 1, so that's going to be minus 8x to the 4th plus 1. And that's all over 16 x to the fourth. Okay. So we get a common denominator. That 1's going to have to become 16x to the fourth over 16x to the fourth. So when we put that common denominator together, everything's going to be over 16x to the fourth. And then we're going to have a 16x to the fourth plus all the other stuff, 16x to the eighth minus 8x to the fourth plus 1, and then that's going to become 16x to the eighth plus 8x to the fourth plus 1, all of that over 16x to the fourth. And now you're probably like, okay, and all that stuff is inside of the square root. Oh my goodness, yuck, disgusting. There's something we have to recognize here. It's really a little bit of a trick, really. When I multiplied this stuff out, that stuff minus 1 times that stuff minus 1, I got 16x to the 8th minus 8x to the 4th plus 1. Notice what I now have is I have a 16x to the 8th and a plus 1, and this time now I have a plus 8x to the 4th. That means this thing right here, this little ugly thing, actually can be factored back to 4x to the 4th plus 1 squared. Okay. So I can write that down as 4x to the 4th plus 1 quantity squared over 16x to the 4th. And it's this idea that I can write all that stuff as something squared that actually lets me be able to work out this integral. Because now I go back and my integral is the integral from 1 to 5 of the square root of that stuff. So this is really the key in being able to do these right now, is that I can rewrite that as something I can then apply the square root to. And that gets the square root problem out of the way. And so again, square root of a square is normally absolute value, but we know that 4x to the 4th plus 1, especially as we're going from 1 to 5, but really in general, that piece is always positive. And so this will be integral 1 to 4 of the square root of that, which would just be stuff inside. 4x to the 4th plus 1. And then square root of 16x to the 4th would be 4x squared. And now we're on the home stretch of this integral. We're on the home stretch of this integral. Because we can now divide both top and bottom by the 4x squared and get the integral from 1 to 5 of 4x to the 4th over 4x squared will just be x squared plus 1 over 4 will be 1/4, and then having an x squared in the bottom is the same as an x to the minus 2nd dx. And so now we can apply our integral rule. So that will be 1/3 x cubed. And for x to the minus 2nd, we'd add 1 to it, it would be -1. So it'd be x to the minus 1, but then we divide by the -1. So that'll make that minus 1 over 4x. Evaluate it between 1 and 5. So we have this really weird, unique function here that we're dealing with, where its arc length actually turns out to be very darn similar to the original function itself. Very darn similar. Not exactly the same, but darn close to the original function itself. And then it's just a matter of evaluating that, plugging in 5, getting an answer, plugging in 1, getting an answer, and taking the difference. And so when you do that, take that difference, you will get 41 and 8/15. 41 and 8/15. So it's very essential here for us that this thing, when we simplify inside, becomes something we can really bring out of the square root and have something that we can then integrate. And not many problems do that. So the ones you're going to be running into that you're going to be asked to work out by hand are going to be ones that will work out. They have to be handcrafted pretty much, so it works out for you.